Okay, ladies and gentlemen, thanks for your patience. As you can see, there was some setup to be done, but so without further ado, I'll pass you over to Domokos Nagy.
Thank you. So welcome everyone. I have my voice. So let me warm up this session. So when I work from home, I have some challenges. Who has kids at home? Raise your hand. Kids? You? Okay. So you know when I'm talking about challenges, you know what does it mean. So I have 2 daughters, and we have unexpected amount of slots, fluffy slots at home, like this. And one time when I was working on this project, okay, thank you. When I was working on this project, she's the most clever one, and realized that when I was working on this wheel, and I found all of the challenges and passed through them, finally I can spin that wheel, and it was really appealing to her, and I could not detach from this project anymore. So we have slots, and she really excited to spin that wheel. So let's get started. I would like to start with the schedule for today. Here is the when we go through the automotive basics, just to understand our attacking steps. We'll have a really preparated attack tree when we go through, and so the first half we're gonna see more theoretical and more basic stuff, and then we go through the consoles and bash script to see how we can spin that wheel. So my name is Domi. I've been working in the field of cybersecurity for almost 15 years, and I have offensive and defensive background, both in vulnerability assessment to investigations. And I have a master's degree, and there was a time I collected certifications. And a year ago, I challenged myself to change to leave the IT security and go to product. And I found a good way that I joined to the product cybersecurity at ThyssenKrupp. And I like the idea how to extend the extent activity with automotive as well. And I'm a happy owner of Mazda 6, so I personally involved in this stuff. And here's our disclaimer. So the following demo was prepared for training and educational purposes, and do not try to use any information for hacking against cars and car components. Thanks. So let's get started. We all know that safety is more than important in modern vehicles, but the question is for today that what about cybersecurity? So do you remember Charlie Miller and Chris Volosek car hackings in the past 10 years? They had awesome researches, and it was eye-opener, not just to me, for the whole industry. So maybe 9 years ago, Charlie was here, presented their findings, and it was awesome for me. So today we will take a closer look how to hack into the car component, and we will use in black box approach. So we don't know anything about our target. I don't know. I don't care. I will just want to reveal brute force and finally find my way to use for my purposes. And there are some challenges on the road. So we need to understand how we can talk with this device, how we can have access, find weaknesses in security implementation, and if we find them, we try to invoke routines, implemented routines, and one may spin that wheel. So let's get started. Let me introduce our attack tree. So, this is the first step. So we need to understand that if we are in the car, we have some kind of network, and there are ECUs, electronic control units, and physically connected together. And I have a hint. So CAN bus is used most in cars nowadays. So we will focus on CAN. What what is it? So it's a control area network, and as we have this, it's something like similar in the IT world that we have Ethernet and ERP, so it's in the physical data link layer. And the problem to me as an attacker that there are dozens of ECUs hanging on the same bus, which is an analyst nightmare because they are so talkative and we have many communication. So if we have a capture, we will see some kind of mess. And we need to understand what kind of IDs we need to focus on. So if we have a special target, we need to find it. And maybe you can find your target by its ID. I don't know which one is which one. And after the ID, usually in a CAN, you have the data. We will cover it later what's inside. So how are we gonna do? Let's disconnect the target device, mount from the car. Maybe it's a hard part, so maybe it's easier just to detach from the CAN bus and connect your tester tool for that on that point and set up your tester environment, wake it up, find the signals, and try to communicate with it. Sounds easy, but just one more question. Maybe on what communication protocol? So we have UDS, Unified Diagnostic Services. It's in all modern cars, and with the car diagnostic tool, you can talk in this language with car ECUs. So as it's a communication protocol, it's on the top of CAN. In an application layer, we have UDS, and in practice, as a tester, with client, we have ECU as a server, which offers access to its services. And if you know what kind of services there and how to request some kind of things based on the service and its parameters, you will get back some kind of service-specific information as a response. In case of positive response, it can be different by service to service. In case of negative response, it's a fixed message format at the beginning with a 7F, and then the rejected service ID, and then a negative response code. So let me peel this layer. So it means that this is the cause of rejection, what you can get. So let me rephrase it. So if I, in the IT world, as a web server, with the web server, do you provide access logs to your client? No. And what's the problem here? If you request a service, you will get back a non-existing service. You will get back a service not supported. So isn't that something that should be hidden from the bad guys? Yes, but this is the word of UDS. So let me show a small message flow that we are usually, when start up a device, in the default session. By default, there are few services. You need to extend your session to a non-default one to get more services to work on the device. And this can be done by session control. So requesting a session to extend your session to level 3, you will get back a response, and if it's a positive response, your session extended to this one, to level 3. In case of negative response, it will start with a 7F, the rejected service ID, which is 10, and then a negative response code. In this case, it's 12, subfunction not supported. What does it mean? That my session control service 10, and the requested level is 5, the requested session was 5, and it was rejected because subfunction not supported, but the subfunction was the session, so that session level, session 5 is not existing in this system. So thanks to the NRC, we can figure out what is available in a device. So here is our setup. We have a powered steering. It's preparated with a custom firmware. It's totally different than what you can see on the road. It's prepared for a security weakness, and it's else you can find this. And it's connected in a CAN bus with a CAN interface to this laptop by USB, and this USB added to my virtual machine, which has Linux, open source tools, CAN utils. What you want to do is just to start to communicate with it. So the first thing we usually see in an unknown network, just to listen. So we started with sniffing on the bus with CAN sniff, and we could see periodical messages. So it's always changing. The red bytes are always changing. I don't know. It's some kind of information, current value of something, the direction, the angle, the torque, or anything. But these droids are not the ones you are looking for, because you need to find a server which will respond to you. So we need to identify which CAN IDs can be used for our attacking scenario, and by session request, which we know that you can request on this issue a normal session request to the default session, and you can wait for the positive responses, and if you enumerate all of the CAN IDs, you will find your ones. So enumerating all of the CAN IDs with CAN send tool, here are our responses. I used a search. Okay, so I used the filter for only the positive responses for the default session change. And there are only two ones. So we have CAN IDs where we can send messages, and then we know which CAN ID will get back some response. That's good. That was the first step what we need. So we have CAN IDs, and now we know that we need to go for the UDS messages. The first thing, what kind of sessions are in the system available? So there is a manual request for 10.01 for the default, and maybe I tried an unknown one, 21, and see the differences between the results. For the default one, we get a positive response in the green box, and we have negative response for an unknown service session 21. As we know, the negative response code NRC12, it's subfunction not supported, which means that session is not available. Okay, enumerating all of the session levels, we found the extended session. So we know that we need to go for an extended session to find good services. Going to extended session. Okay. Which kind of services are available? We know that the session control is there. So on the second line, it's requesting. It's a session control request without parameters. So it's a easy triced in our case. And for the 10, we get back a negative response code, which means that subfunction. So this means that the service is available, but its subfunction was wrong. However, in other case, for example, service 9, we get back NRC 11, service not supported. What does it mean? I'm interested in the supported services, so filter out the non-supported services. Thanks to the NRC, it can be done. Enumerating all of the services, we get back the not supported ones. So we found services. What kind of services are there? Obviously we have diagnostic session control, which can be used to extend our session to a diagnostic session to unlock additional diagnostic functions. We have issue reset, may be good sometimes to go back to the baseline and start anything from the beginning. We have security access to requesting seeds and then sending calculated keys and get authenticated, get access to something which is secured. And we have routine control. Maybe that's the most interesting one, because routine control can call routines, implemented routines, and one may spin that wheel. So that's a good one. And tester present, it helps to keep alive your session. So where we are, we know services, and we start to hunt down the most interesting one, the routine control. Routine control flow shows you that it's a service ID, it has a service ID 31 and the start routine 01. So with this, you can request to start a routine. That's all what we need. So we just try to start a routine, and if the routine is there and it's, everything is okay, we get back a positive response, service ID plus 40. The routine start byte is there, and here is the routine ID, is 2 bytes. So if you want to start this routine and you get back a positive response, it means that this routine is executed. That's good. In the other case, if you get back some negative responses, you need to understand that this was the rejected service ID, and what is the negative response code. And high five to NRC again, we see that security access denied. That's the point where we need to understand that, okay, there are routines, but you need to elevate your security level to go there and run that routine. So this routine ID, F1, AB, was not performed in this case because it's a negative response. So get it real. We started by manually the first few routine IDs, 3101 and from 0 to 3. And we get back always the same negative response code 31, which said that it's out of range. In this case, it means that that routine ID 0, 1, 2, 3 was not there. So the only thing we need to do at first, just filter out this kind of negative responses. Maybe one has different response. And enumerating all of the routine IDs by script, you will get back in a green only one different routine ID and with a different response, negative response. As we've seen before, NRC 33, so it's security access denied. So where we are, we know that there is a routine which can be called, but we need to have kind of access, kind of security authentication to run this. That's where we are, and here is our attacking tree. So we need to step back and go to security access. We need to bypass somehow the security, find some weaknesses. So I promise this is the last message flow we need to cover, and this is also useful for our capture the flag game. So service ID is 27, security level from 1, and added by 2. You can authenticate yourself, requesting, in this first case, there is a security access request for seed for the level 1. And if in case of positive response, so the security level is there, you get back a positive response with a seed. It can be 1 byte, 2 bytes, 3 bytes more, and maybe it's good to understand that if it's small, you can build up your dictionary and try to guess all of the possible keys for a seed, and you will build up your dictionary and you will find a key. Maybe it's useful later. However, if you get back a seed in normal way, you need to understand, you need to know the security algorithm and the secret key, and then you can send back a key. Based on this process, you need to add one more to the security level, and then you can send your calculated key. If it's good, you will get back the service ID plus 40, and it's some function. So it's okay, it's positive, it's authenticated, so you are in the security level 1. And based on this process, you need to understand that you need a security access level and then a good key. That's all what you need. What we need, but we don't know about too much about the security process in this device. So what we need to do, figure out everything about this service. So going to the live demo part, we will try to find out available security levels. We will analyze the seats, maybe it's random or not, the length, and what's the behavior after visit. We will do the same on the security keys, calculated keys. Maybe we need to brute force the key space, and as we have Google and the standards, we know all of the NRCs, so everything can go wrong, but NRC will help. This is the demo time. And I need just a minute to change my desktop. Okay. And for doing that, I would like to use a webcam just to see if you are seated in the back, to see what's going on, because we are focusing how to bypass the security, then how we can call the routine to spin that wheel. So that's why we need to see this cam to focus our target. What's the password? So this is the live demo part, everything can go wrong. Okay, so we have a CAN interface. What's the password? Should be up and running. Yes, it's there. And okay, maybe I need to zoom in. Okay, so we will use the right part of the screen to see the responses, the messages that sent out and the responses from the ECU. We'll use the left part to send some CAN messages. And I have prepared scripts. So first, we need to enumerate all the security levels. One may respond differently. Going through this process. Okay, let me stop it. So at the first, as you see, after the extended session, we'll get always back negative responses, and one is different. So we have a positive response. What is the positive response? 67, which is the positive response for 27, and we have its requested security level. It's 0B. Maybe we can use a different filter just to get closer this word. And I will highlight this again. So going through all of the security levels, I filtered out all of the negative responses which we are not interested, and filtered only for those responses were positive responses, and check the line before what was the request. So we know that we requested level B, and we get back a positive response. So we know what is the security level. 1 checked. The next one, we need to request seeds on this level to see what kind of seeding is there. I don't know, so we check all. And I'm filtering only for the responses. I'm not interested what I sent out because I know what is there. So as we see, there always get back seeds. So 67 0B and 0B, and then seeds. It's kind of randomness, so it's not good for a quick win. We can use it to build up our dictionary. We'll skip that way, and we try to see what's the behavior after reset. So in the next example, we will send out a ECU reset and see what is changed. So from now, we have an extended session and get back seeds. Oops. And in the positive responses, the seeds are always the same, 42, 42, 42, 9 or 10 times. So in the first 10 seconds, let me stop it. In the first 10 seconds, we will have a fixed seed. What does it mean? That if we have a challenge, it's a fixed seed, we can answer a fixed. We should find a fixed answer, which is we need to send back to the server to authenticate it. So we can brute force the key space, and one will help. Let's go deeper. 6, 7, and brute forcing the keys. So after reset, okay, let me stop it. I see. So what's the problem? At first, here is our seed, and then what happened? We get back always a negative response. And what is the negative response code? 35, then 24. Okay, I have a help from Google or anywhere else. 35 means that invalid key. So I had a key attempt, tried a key, and it was invalid. That's good. And after that, what happened? I get back 24s, which means request sequence error, because I will show you what's the problem. So the problem is that after reset, into extended session, we have a seed request, and then in a loop, just sending keys. And this is not good. It's not in the process. So you need to request a seed and after a key, and do it again, time by time. So going to the next one, and let me check. Right. Okay, going through. Let me stop it. So in the next example, we get back a seed and then invalid key, and then a seed and then invalid key. So we try the key and we get back a negative response. It's not there, it's not there, it's not there. Going through. Let me just filter out this noise. And what is the noise? So I'm more interested in everything else, but not the seed. That's good. Oh, that's not good. Again. I didn't say that it's easy. It's easy weaknesses, but we have some challenges. So the next step is that after 1, 2, 3, 4, 5 attempts, we get back negative response 36 and then a 37. What does it mean? Exceeded number of attempts and then required time delay not expired. Brute force protection is there. It's not good. It's not an easy win. We need to work with this. So what we did, we sent out 5 different keys, got back invalid keys, negative response, and then it's banned. So we need to work in a loop and reset the ECU time by time. That's why we have script kiddies and wrote different scripts. Okay, so this one is the next one. So what we're gonna do is just to see so we're gonna do that. We are interested all of the CAN IDs started with 7 and filtering for the positive responses, because we know the security access protocol, sending a request for seed, then get back a positive response with a seed, and then sending a key with security level +1. So if we have a 0B level, we need to go to, we are interested in the 0C in a positive response. And in this case, there is a small chance that we will find a good key. can time consuming if we started from 1 byte, from 0 to FF, and go further, and we need to reset time by time. So it depends on the key space and the delays. It can be a minute or more. Yeah, okay. So let me stop it. So you need to understand that the key space is only 1 byte, and the seed is always here is just 1 byte. So here is the whole process. We have a security seed request for 0B. We get a positive response with the seed. Then we have a calculated key. We brute forced all of them, but this one is the only one who had a positive response. So we have a positive response for the 0C. It means that we are authenticated to the level B. So I think we bypass the security, so we need to rerun the routine, and it should be there. Okay, let me. So let me warn you that the routine will be executed. I'm really expected that something gonna happen. So see everything. Let's start the dump. Let's start the routine. So what we're gonna do, authenticate it to the security level and call back the routine, which we know what is the routine ID. Sending this out. And yes, a negative response again. Sorry guys, this is the way when we authenticate it to the level B, we have a positive response with level C, and then we started the routine, but what went wrong? NRC. I need to check it. 13, incorrect message length. So we call the routine, and you need to understand that here is the length of the CAM message, and with 4 it means that I used the routine control, started the routine with the routine ID in 2 bytes and without parameters. So the incorrect message length means that we need to extend this length and get some parameters. Last chance. Okay, so here is my last script, and after an ECU reset, we're gonna go to extended session, access to security level B, requesting a seed, sending a well-known key, which we had, and if it's granted, we call the routine. In the previous step, we called the routine with 4. It was not work. So we will call it with length 5, and I placed FF at that byte. And then I will call with length 2, with length 6, which means that a parameter has 2 bytes, so I just added FF on the last one. And going through, I tried all of them. So let's have a chance to do it. And sorry, I need to reply that. All right, so last chance. There is no voice, no sound in the jack. Okay, do we have a sound in jack? No? Okay, we can skip this. So I'm really excited to spin that wheel. Slot is there. Level is there. The key is there. Security granted. 1, length 1, length 2, and 3. Thanks. Okay. Okay, let's finish this previous up. We have 5 minutes, I hope. So as we have two parameters, I understand which is what. So one is for direction. Oh, sorry, it went wrong. So I just skip some steps. So one parameter is for the direction and one parameter is for the speed. So spin that wheel slowly like that. It's okay, and going to the presentation. Oops. Just meanwhile I found. Oops. Slotty worked well. And here we are. So after this of some demo time, going back, so we understand that we have routing and security access denied. We need to understand that there's a lack of entropy. So in the first few seconds, we have no random, just a fixed seed. It means that no entropy. And the small key space, small key, small seed, small key, and a weak brute force protection, because we could try 5 keys each time, means that we went through all of the process and security bypassed. So what we see is the wheel spin. So some conclusions that while UDS in all vehicles, by default there is no cybersecurity, and keeping in mind that possible effects on safety, you need to require, design and implement the layers of it, and it can be weak, it can be, I don't know, we have seen many things in the past, so what I would like to highlight here is just we need to validate somehow, we need to test our stuff, and this is all about this presentation, and that's all you need. So you need testers who can spin that wheel, and thank you. Maybe just one more thing, that come to our booth, challenge yourself, and have some prizes.
Yeah,
based on this demo.
Please do. The closing time for the Thyssen competition or challenge isn't quite known yet. The Bosch will close at 3 o'clock. All of the winners will be announced here for each of the 3 challenges. The winners announced and the prizes given sometime after 3 this afternoon. When I know exactly the times for those announcements, I'll of course let you know. Now it's time for break. The mid-morning session will recommence at 11:15, so if you can be back please for 11:15. Domokos, again, thank you.